my autonomous energy generator video. What I'm going to show today is what's all involved in creating the generator part of it, as well as in the lower unit, which is the actual autonomous energy where it's created. As you'll see, this is everything that's used in the top, so I don't want to cast any dispersions on what's actually inside of it. That voltmeter right there is generally not inside of it. That's the only piece that won't go inside of it when I put the cover back on it. As you can see, it's just a voltmeter, 2,000 watt power inverter, and a 200 watt power unit. Basically, what you'll see here before I put the lid back on is basically I'm just going to show that the power generator, all it's doing is giving the start power to the lower unit. And you'll notice on the voltmeter that you'll have degradation. And what the concept is the power starts the lower unit. The lower unit then creates enough power to charge the power unit and keep it from degrading, as well as it powers the 2,000 watt inverter. And so it's a circle of energy that's a constant. And so that's what I'm going to show here today. So let me first turn it on, show you how many volts it actually produces just from power. That shows you how it inevitably charges and powers everything in the device. I also show you that the fact is that power storage, as it's connected there, you'll notice on the voltmeter it's going to degrade. And so there's no situation where you can't get degradation of power from a power unit, and that's why you have to have this whole energy generation system in order to create autonomous energy. All right, let's get started. All right, you look at the voltmeter. I'll bring it closer. The voltmeter says 0. And then I'm going to turn on the power. There you go, 64.4 volts. And so obviously that's only 12 volts. That can't go here. And there's no booster units in this. There's no supercapacitors, no anything in here. And so there you go. That's how much power you're generating from a 12 volt input. And then obviously that in turn charges this, keeps this powered up, as well as charges powers the inverter. And you'll see here, I'm going to leave it on here because it's going to show you that it degrades. There it goes. It's already degrading. So there's no possible way when you see later that this unit right here keeps a constant volt. And it will keep a constant volt. I can't show you, but it will keep a constant volt for the life of the all these products is probably about 10 to 15 years. And so this unit, when it's fully operational, will just power this unit and whatever's attached to it for 10 to 15 years. And that's what I'm going to show you here today. And see there, you see it degrading again. So it just keeps degrading. So just know when you see later when this whole unit's functioning, it doesn't degrade at all. It's not possible to run anything off of a battery without degradation. It would take way too much power. And as you notice, there's not any room any more in here. And you can see the top there. That's what it looks like. This just fits right over top of these. You can't put anything else in here. And plus, it wouldn't matter if you put 2 more of these in here. It would still degrade. All right. Okay. Another thing I want to show is that this is not connected to anything. You'll see I have a barrier here, but I'm going to move the unit around just to show you there's nothing connected to this. Nothing over there, no cables. It's the same thing, everything's connected to this. So there's the inside of it. Nothing's in there. spin this thing around all the way around. Show you there's no other wires, there's nothing underneath it, it's cement floors, there's nothing coming out of the floor. It's just the unit itself. And this is all that's going to be inside of that cage once I put it on. You have to put the cage on, and I had to design it with fans, a pass-through cooling fan, because this guy right here, between this guy and this guy, it starts heating up. This produces no heat whatsoever, which is part of the whole autonomous energy generation piece. Is the highest proficiency. Humans don't even know that level of proficiency yet until this invention comes out to market. So this generates no heat. These two guys generate a lot of heat, and so that's why you get the cooling process blowing out. Alright, technically down, we're down to one now. So just once again showing the fact that when you see the whole unit functioning and there's no degradations, it's just not possible. Alright, next step, I'm gonna put the top back on it, and I'm gonna run the whole system. Alright, thank you. Alright, here we're back. This unit is set up now. I don't know if you can see it. We'll zoom in. It's producing 120 volts. Should be able to see on the camera. Real only sound you should hear is between the inverter and the two side fans, which I'll show you here in a minute. You'll notice that the meter fluctuates every once in a while. I found out that it's the inverter that's doing that, but it'll stay at 120 volts for approximately 10 to 15 years. Alright, I'm going to scoot back out so I can show you, rotate it one more time, show you that it's not connected to anything. You can see the top and the bottom at this point. Sorry, the cart is kind of difficult to turn. I want to move. Cement floor, once again, it's no cables connected to it. As you can see, as I rotate, you can see the fans. That's what's making most of the noise. Once again, unlike the last video, where it showed what's in the top, it makes it the generator. Because once again, the invention is the lower unit. It's not what's in the top unit. The top unit, this is a potential energy source. This is just the part that makes it a generator, which you need all those components to power stuff. Potential energy, not necessarily is going to ever power anything by itself, but without all the other components to make it a generator. So if you're looking for a potential energy source that powers stuff and generates all the power. Good luck with that. We don't know it at this point, so I'm not sure what we're going to but this is the next step to possibly getting there. Once again, you'll see it's staying at 120 volts AC. And you'll see it once again, it goes up and down slightly, but that's the inverter and has nothing to do with the power unit. And so basically what you're seeing here is the lower unit, once again, is charging that power unit I showed you in the last video, and is also powering the inverter. And then it's just a circle of energy, one charging the other, to make it perpetual energy. Alright, I'm going to plug something into it. Step this back again. Sorry for all the camera movement. Bring on my turkey fan. As you saw, I plugged the fan into it. It was high. Again, you'll see the, obviously the meter gets a drain. It's telling you what the excess power is from using the fan, so you still got 116. It's probably pulling about 60 to 80 watts. Now it's been requested that I go and I plug in a whole bunch of different items into this, but as you can tell, you should know by yourself that if that's a 2,000 watt inverter, it's pretty much made to power everything that you could possibly want in a construction site. So I could sit here all day and plug in random items just to show you what draw they have on them, but we should all know what that is. So I'm going to just use the fan today, show that it's pulling power, meter's telling you how much it's pulling, and then it's telling you how much you have left. So once again, what you're seeing here is the lower unit is your potential energy. It's generating 62 volts. It's charging that power unit and powering the inverter. Meanwhile, the power unit, the only thing it's doing is giving the ignition to the lower unit. And so yes, as you saw in the original video, the lower unit will pull so much power from the power unit, more than this fan is, that it's going to degrade the power, so you can't possibly keep constant power if you're just running it off of a power storage. You need the circle of power to charge each other, power and charge each other, and also charge whatever's attached to it. That's autonomous energy. So that's the biggest thing you're going to get from this video, is you're going to have to understand what's happening and what has to happen. If this was a windmill or if this was a river with a dam on it, that's the water. That's the wind. That's not all the energy requirements to make up what you know as DC and AC voltage. That's a potential energy source. That's wind. That's fire. That's an explosion in a car engine. That's water in a dam. That's not the power stations where you get your power from. That's not a nuclear silo. Those aren't potential energy sources. Steam generated from a nuclear power plant, that's not potential energy. The plutonium is the potential energy. The potential energy will give you no energy. It just gives you heat. This actually gives you energy, and you saw it. You saw it gave you 62 volts. All we had to do is give it 12 volts, and it's going to give you 62 at 662 watts. And it's going to power everything that you attach to it to make a generator. All right, I'm going to take it off, and we're going to take a look at it, see if it bounces right back like it's going to. There you go. And that's the inverter, once again. The inverter's got, obviously, it's got supercapacitors in it, and that's just it charging from the energy that it's getting from the potential energy source below. All right, and then the last video, I'm going to make one more video, and that will be a time lapse, and we're just going to let it sit here for probably a few hours and see if there's any change. Thank you.